The next presentation is from Dr. Filiz Yapici, that she studied chemistry at Heinrich Heine University in Düsseldorf and did her PhD in physical chemistry at Henkel within the laundry and home care department. After her PhD, Dr. Filiz Yapici joined to Levaco Chemicals in Leverkusen as a technical manager in the Agro Solutions business unit, and she has been with the company for over 3 years, continuing to apply her deep knowledge and skills in formulation and new product development and addressing challenge in the agricultural market. Okay?
Thank you. Thank you for the nice introduction.
Tenéis, bueno, la traducción está aquí puesta. You can press here
Yes.
or pass the
Thank
slides.
you. Thank you.
You can
I
pass
can
the
just here pass.
next. Next more.
Okay.
Yeah.
So, buenos dias. It's a really great honor for me to be here today and to present our latest development on biodegradable film forming agent. I have to talk in English, unfortunately. I'm not so well equipped in Spanish, so I hope that it's okay for you. So my talk is divided into several parts. First of all, I give you a short introduction on the topic of microplastic. I will explain you the scope and the definition and will come to the derogation criteria. And afterwards, I will come to the introduction of Lucrop SRF and will present the physical properties as well as the potential application fields. So the scope of the microplastics, according to the EU restrictions, products containing more than 0.01% of intentionally added polymers are added microplastics are not allowed to be used in the EU market. And here the question is, what means intentionally added? This means that this addition brings specific benefits into the formulation, it changes the physical properties or solve any formulation challenges. And in this overview, you can see the product groups, the different product groups, the usage of tons per year and the release to the environment. And it is estimated that overall 154,000 tons of microplastics are used in the EU and EEA market. Regarding the product group agriculture for plant protection products, the intentionally addition includes like the encapsulation of active ingredients or, for example, also the formation of a film for seed coating or seed treatment. Coming to the definition of microplastics, microplastic is a solid particle containing more than 1% of synthetic polymer with a size range up to 5 nanometers. And this can include either a continuous solid polymer surface with any thickness for coating applications like for seed coating, or it is any composition with a solid polymer content more than 1%. So here the question is, how we can overcome all the challenges on the topic of microplastics. And for this, the two committees, RAC and CAC, has defined the so-called derogation criteria that can be found in their latest report from 2020. And they include like polymers of a natural background without any chemical derivation that are free of microplastics, or the polymers has the ability to be biodegradable and has a water solubility above 2 grams per liter. Furthermore, substances are not considered as microplastic when the physical properties are permanently changed or permanently modified, or when they are completely changed, for example, when they are able to form a film over the surface. And the last point is the microplastic is permanently incorporated into a solid matrix. And this is, for example, in case of adhesives or concretes. So after presenting all the topic of microplastic, how we overcome these challenges with the derogation criteria, I want to introduce our latest development, Lucrop SRF. Lucrop SRF is completely based on a polysaccharide blend. It consists only biodegradable ingredients. It is completely free of the topic of microplastics. It is based on water. It is an aqueous solution and has an active amount of 70%, and it is readily biodegradable. That was determined according to the OECD method 301B. And this means that the biodegradability is higher than 60%. So Lucrop SRF presents a sustainable alternative to traditional polymer emulsion latex, for example, in case of polyacrylates or polystyrenes, because they are not biodegradable and not water soluble. So they are completely targeted by the microplastic definition. A further advantage of this product is that it can be applied as in-can formulation into an existing formulation, or additionally as a tank mix adjuvant. It is free of any hazard labels, and it is EPA approved as an inert ingredient for pesticide formulations. Coming now to the physical properties of SRF, this product is able to combine 3 different properties into one convenient product. I'm talking from film forming, adhesion, and rain fastness properties, as it is able to form a protective film over the target surface, acting as a barrier. It has sticky properties, and this improves that the pesticide sprays can stick onto the target surface, and the droplets becoming inelastic, and this reduces the runoff or the bounce off on leaves. And one of the main advantages is it shows a very, very high rain fastness characteristics. So when a film is formed over the target surface, it is very resistant against wash off by rain, for example. And here, as this product is mostly acting on the surface of the target, we recommend it to be used in combination with contact pesticides rather than systemic pesticides, because systemic pesticides can be absorbed by the leaf. However, contact pesticides, they have to act on the surface. And as herbicides, we recommend like glyphosates or glufosinate, and fungicides like copper salts, sulfur, zinc, captan. So regarding the film forming properties, we tried to show this ability in our lab. So we prepared an aqueous solution with an active amount of 2% and used a blue dye just to visualize the film, because the film that is prepared is formed as transparent. Then we allowed that the solution air dried for 1 day, and after drying, a film was formed. And maybe why we have chosen this setup, because we compared the properties of our product with a reference product. And as a reference product forms the film also after 1 day, we have chosen this time for drying process. And here you can see the film formation of SRF with methylene blue and the reference product. So you see a comparable behavior to the reference product. Then the question was how we can show the adhesion properties of SRF, and therefore we have designed a very creative setup in the lab, because we have coated a 1 cent coin with a cellulose cloth and put it onto the prepared film, and then the coin was moved up with a defined angle, and the time at which the coin slipped off was noted as the so-called slip-off time. And here are the screenshots from the video. So the 1 cent coin is on the top of the film, and then we move up the film with a defined angle, and then it slips off. And this is the same experiment with the reference product. And you see with SRF, the slip-off time is 2,200 milliseconds, and with the reference product is quite lower. And here we can see that SRF is able to act comparable or even better than the reference product. Here we want to outline now the rain fastness properties of SRF. Herefore, we prepared aqueous solutions of 0.05% SRF. Why this low concentration? Because here the idea behind this was the usage of SRF as a tank mix adjuvant, and therefore just 0.05%. And we use UV dye just to visualize the droplets under the UV lamp. So we sprayed it onto the banana leaves and air dried it for 24 hours, and then we simulated the rain. So we sprayed the leaf surface with water from 10 up to 40 spray applications. Here so you see the results without SRF. It is just water and the fluorescent dye. After 10 times of spray application, where we have very, very small droplets distributed everywhere, and after 40 times of spray application, the dye is completely washed off. And now you can see the result with SRF. You see we have larger droplets, evenly spread onto the surface, and remarkable, after 40 times of spray application, more than 50% of the dye remains on the leaf. And here to show how the reference product acts, when you compare like the 10 times of spray application, you see also the formation of larger droplets, however not so evenly distributed like SRF. And after 40 times of spray application, it also completely gets washed off, even it contains a film-forming agent. And here you can see that SRF shows a better coverage and has a higher water resistant rather than the reference product. And now after we find out these film-forming properties, the idea was how we can improve the spreading on the surface, how we can improve the rain fastness. And therefore, we tried to use wetting agents. We screened different wetting agents, but as we wanted to present a green solution, a biodegradable solution, we mostly worked with biodegradable wetting agents like amine oxides, sulfosuccinides, APG, alkyl-polyglycosides, and beta-ene type surfactant. And here you see this is a premix containing of 85% of SRF and 15% of wetting agent. And the compatibility has been checked after storage at room temperature and 54 degrees for 2 weeks. And after the storage, we didn't see any separation, any sedimentation, or any color change. So they were highly compatible. We did the same test also with the conventional wetting agents just to see the effect of the mostly in the market used products like fatty alcohols that are ethoxylated and propoxylated. However, with the conventional wetting agents, it's completely separated and the product was incompatible. And then we tried the same rain fastness experiment with the same setup, and we prepared first the premix containing 85% SRF, 15% wetting agent. We diluted it to 0.05% application concentration, allowed to air dry for 1 day, and then simulated the rain. Just to remember, the rain fastness trials only with SRF, without any wetting agent. And now you can see with the addition of beta-ene type surfactant and with APG. You see that the coverage is highly influenced and highly improved by the addition of wetting agents. They are evenly distributed. And remarkable, after 40 times of spray application, around 65% remains on the leaf. And in case of APG, we see also slightly better performance than the beta-ene type surfactant. So during the development of SRF, we find out that SRF is also highly compatible towards high salinity environments. And this brought us to the idea to check also the performance as crystal growth inhibitor. Because as you know, for supersaturated solutions, they tend to crystallize. Shortly, the background supersaturation, when the solution contains more solute, then it can be dissolved, and the excess is not dissolved into the formulation. And these are thermodynamically complete metastable. And so they tend to go towards the more stable state, and this happens when they precipitate out in form of solid crystals. And in the absence of any nucleation sites or under the influence of crystal growth inhibitors, the supersaturated state can be prolonged. And as a model substance, we have chosen potassium chloride because it is also used, can be found highly in the scientific literature. You can see the solubility curve of potassium chloride against the temperature. And first we have prepared the supersaturated salt solution. First of all, we dissolve the respective amount at 20 degrees and increase the temperature up to 40 degrees, just to increase the solubility of the salt. And then we added more potassium chloride and then cooled down the temperature to room temperature, and the excess of the salt precipitated in form of solid crystals. The appearance of the supersaturated solution and the crystallization, we showed it with the so-called Petri dish setup, because the glass with a glass rod acting as a substrate with a smooth surface and triggers the crystallization of the supersaturated solution. And here you can see the behavior without any adjuvants. So after 1 minute, we have many formation of crystals like in the shape of plates. And after 30 minutes, more crystals, and also the size is growing. And this are photos, screenshots from a video. You can see the whole video after the lecture in our booth of Ricardo Molina, where we want to can show you also the complete video with and without adjuvant. Now with 2.5 and 4% Lucrop SRF, you see that the crystal growth is prolonged. After 1 minute, you don't have any crystals, and after 30 minutes, smaller crystals are formed. And with increasing SRF concentration, also the amount of crystal formation is highly reduced. And as we worked on this system, we thought also about NPK fertilizer, about problematic NPK fertilizer. They tend to crystallize. And this was just one case. You see very many of crystal formation, very large crystals. And now with SRF, it is remarkably reduced. And here we just summarize the major advantages of SRF regarding the crystal growth topic. We have a better handling, a homogeneous appearance, and as it can prevent or reduce the crystallization, we don't have any clogging on the spray nozzles. Then coming to the last potential application field where we think that it can be also very beneficial is as a binder for seed treatment. And here we use an FS recipe containing tebuconazole as active ingredient. Lucramol PPSA16 is our manufactured product of Levaco. It is a 3-stereophenol ethoxylate that is phosphated. It acts as a dispersing agent. Lucrafoam SO6 is also a developed product by Levaco. It is a silicone-based defoaming agent. Then we used as a pigment, a solid pigment, a pigment blue, as a binder SRF with 2%. So here the addition is like an in-can application. Propylene glycol is an antifreezing agent, and we used combination of rheological modifier. And this is the particle size measurement of the formulation before and after a hot storage test. And you see just a slightly change. However, the particle size is lower than 10 microns, and therefore it's no issue on the quality. And for seed coating, we used wheat seeds, and you see the coverage of the diluted formulation after 1 day, very well coated. And I did the same experiment with a more complicated formulation containing tebuconazole and proteoconazole as combined active ingredients, where we don't have any shift after the storage test. And here you see the coating on wheat seeds and on soybeans. So to summarize, I don't know why it is so. Oh, okay, very small. So SRF is made up completely of biodegradable ingredients. It represents a sustainable alternative to traditional use polymers. It can combine stickiness, rain fastness, film form into one convenient product. It can act as crystal growth inhibitor and as a binder for seed treatment. So here I want to thank my team of the AgroLab who did all the experimental trials, and I will also want to thank our agro department. And muchas gracias for your nice. So thank you. Thank you.
Thank you very much.
You're welcome. Thank you.
Well, bueno, tenemos pocos minutos, pero podemos hacer alguna pregunta a las dos ponentes. Cristina.
Sí, muchas gracias a un segundo. Una pregunta para...
Espera, Cristina.
Gracias. Tengo muchas gracias a las dos por dar estas presentaciones sobre nuevos productos que podemos esperar en el futuro. Tengo una pregunta para Teresa y es el origen del aceite esencial. ¿Nos puedes decir alguna cosa? ¿Dónde se pensaría cultivarlo o extraerlo?
¿Te refieres al origen de la
Sí,
de la
geográfico, ¿no? O sea, tiene un impacto en nueva producción,
Es que no te entiendo.
No me has entendido la pregunta, ¿no? O sea, ¿dónde planea? No exactamente,
Vale,
pero ¿en qué área geográfica?
La materia prima, ¿de dónde pensamos
Exactamente,
tenerla?
porque cuando hablamos de un producto sostenible, creo que justamente lo que estamos entendiendo es pensar toda esa cadena de valor, ¿no? Entonces yo me preguntaba, ¿vas a ser un producto de origen biológico? Si nos puedes decir más algo de también en qué impacto tiene en ese cambio de extracción.
En cuanto al tema de la obtención de la materia prima en sí, la hoja de eucalipto, porque de hecho estamos pensando, aquí en España en concreto, las plantaciones de eucalipto se pusieron con idea de celulosa. Entonces, lo que se está utilizando es la madera, pero la hoja se está desperdiciando. Al final, el aceite esencial de eucalipto se obtiene de la hoja. La idea que tenemos en mente es aprovechar todo ese residuo, entre comillas, que no se está aprovechando, que es la hoja, poder aprovecharlo de las plantaciones que hay aquí en España. Con lo cual estaríamos solucionando el problema de un residuo y utilizándolo para extraer un aceite esencial que al final como que va a cerrar un poco el círculo. Esa es la idea que tenemos. ¿Vale?
Gracias.
Gracias. Mi pregunta es también para Teresa, en la misma línea que Cristina, pero a nivel económico, el coste del producto final para el agricultor sería, ¿cómo sería? ¿No sería demasiado elevado el precio? Porque, por ejemplo, porque creo que el proceso de producción del aceite esencial es costoso y la cantidad no siempre es importante, no es para el agricultor. Y el precio, ¿cómo sería?
A ver, realmente, tema de precio, estamos hablando que hasta el 2026 no vamos a presentar la sustancia activa, con lo cual hablar de precios de un producto comercial que todavía no está en la calle es adelantar mucho el camino, pero realmente, a mi parecer, ¿vale? Te hablo desde mi punto de vista personal y teniendo en cuenta la filosofía de la empresa. No tiene sentido sacar a la calle un producto nuevo que por tema de precio no sea aplicable. Entonces, la idea es sacar una sustancia activa que sea eficaz, que sea respetuosa, que sea una alternativa a lo que hay hoy en día, pero obviamente económicamente viable para el agricultor. Porque no tendría sentido salir a la calle con un producto fantástico y maravilloso, pero que no sea asumible económicamente por el agricultor, que al final va a ser el que lo va a aplicar, el que lo va a demandar. Entonces, en ese sentido, nuestra idea es ir en esa línea. Ya habrá tiempo de hacer números, pero la idea es esa.
Okay, my question is for Dr. Filiz. And you mentioned about the dosage in the both for the seed coating and for the crystal inhibitor, but you didn't mention the dosage, or I didn't get it, about the foliar applications, because I think this is one product that due to the properties will be most suitable for the foliar applications, for example, such as the oil, eucalyptus oil from that Teresa has presented, and another kind of conventional active materials. So what will be the addition in the formula for the foliar applications that you will recommend?
Regarding these products, we can recommend concentration up to 5%.
Up to 5%.
Up to 5%, yes.
Thank you.
Yeah, before you go there, I have a question for both. Have you tested your different products in different plants? Well, in your case, you present only on seeds. But have you tasted in other matches?
In my case, we just tested on seeds.
Okay. And Teresa?
¿Te refieres a si hemos aplicado nuestros productos
en diferentes plantas o...?
Sí, a ver, realmente cuando empiezas a trabajar con una sustancia activa nueva, llevas un enfoque y empiezas a trabajar un ámbito. Pero cierto es que lo que he comentado anteriormente, más de 30 ensayos en bacteriosis, más de 25 en temas de insectos, pero es que esto no para. Que cada día nos van apareciendo posibilidades nuevas, opciones diferentes, estamos trabajando en un montón de cultivos que inicialmente no habíamos pensado. Entonces la verdad que las posibilidades y las opciones son muy buenas, pero estamos trabajando en el tema hortícolas, cítricos, frutales de hueso, pepita, olivar, que no lo habíamos tenido en cuenta antes, viña, frutos rojos, un montón de cultivos.
Gracias.
I have a question for Dr. Filiz. A couple of questions, in fact.
Okay.
The first one is, I imagine that Lucrop SRF can be used as a rheology modifier. Does this product need a kind of biocide, like, for instance, xanthan needs to prevent the microbial degradation? And the second one is...
maybe coming directly to the first question, SRF not comparable to rheological, like the functions rheological modifier. So we have to split these two topics. It's not acting like, for example, xanthan or silicates.
Okay, and the second one is the compatibility of this product with microbials, with microorganisms.
Yes, with microorganisms. Here we tried several tests with the well-known bacteria strains, with fungus, for example, and we see a compatibility, but it is still in the development phase of our research. However, we want also to grow up also on this field.
Any more questions? No? Okay, so let's finish to this blog. So thank you very much to the two speakers. And it's time to lunch. Perdón, en castellano, ¿no? Nos vamos a comer, ¿vale? Y volvemos otra vez a las 4 aquí, ¿vale? Gracias.
Thank you. Thank you.